Drone racing has gone a long way in the last few years, and autonomous drone racing has spiked since the first autonomous drone race, Autopilot. A new paper by Robotics and Perception Group at ETH Zurich has shown their approach to how to create an autonomous drone. And the structure of the paper helps to explain a whole lot of elements that come together. This is a culmination of drone controllers, autonomous drone controllers, which allow for the drone to plan a path and follow it, and self-driving cars, which is also an area of technology that's more focused on processing data coming from the IMU, the laser rangefinder, the cameras, stereo, and RGB. So, as they showed in this paper, there are these multiple sensors that fuse in the perception to detect gates and for the VIO. So, if you read, you find they used ROVIO, which is an established VIO, and they fuse it to the gate poses, which are detected through a CNN. This is already the first stage of self-driving intelligence that they've placed on the drone. So this is a GPS denied race, and they use they use a NVIDIA Jetson Xavier on board the drone. Then it goes to estimating the state of the drone with an EKF, and the predicted state can help use an MPC controller to, because it's time dependent, to compute total thrust and angular velocity. So all these elements are classic robotic stack for autonomy elements. This is why, but specifically, they're in a GPS denied environment. They're in a specifically drone resource constraining space and at high speeds, so performance is important. So these elements actually change the environment of work. It's incredibly important to think of the drone not as a classical mapping and trajectory following bot, but it has to map according to its inputs, and vitally using optic flow to understand its position, and EKFs to really establish that state. This has been explored in previous papers, as they write about fusing gate information with IMU gate attitude estimates. There's also the use of a CNN for the bounding boxes, and a control law with optic flow to follow towards the detected gate. Essentially, the system that RPG has followed also works when no gate's visible, essentially, because it maps on its own 2D space, and optimizes in real time if the global map is updated. Alright, so having said all this, it seems pretty vital to come back to how to get up to speed with this kind of work. So, separating it into flying vehicles and self-driving vehicles. the flying vehicles needs a planning component, a control component, and an estimation component. Planning in order to transition from state to state in a state-based manner or a more complex way, but this is how it's commonly understood. Control is about taking the point that is established on a trajectory and operating the drone to move towards it. This is hackable in that the drone can have many axes of freedom at choice, and this improves performance. And estimation is even fundamental to that. You cannot have control without state estimation, because the drone that moves from point to point needs to know where it is exactly, what attitude, pose it has. So state estimation is about determining that with a probability of uncertainty using all the information around it, sensor fusion, in this case EKFs. Alright, so all these three elements are required to actually make the drone move. But self-driving cars is this other element that's more tied to artificial intelligence. It's important to be able to gather data in a more intelligent way, whether it be on camera to have bounding boxes around gates, segmentation, and the like, or fuse that with laser rangefinder data, which helps with optic flow and altitude control, and also to fuse that with the stereo cameras for depth perception. So at the DVAC, we work with a few of these technologies. These are a few samples of the work, and we hope to get better soon. I hope this presentation has been quite revealing of the state of autonomous drone racing and autonomous vehicles in general. And this overview helps myself understand it better, and don't hesitate to get in touch. Thank you, and have a good day.